Hey everyone, it's Mr. Canfield. Today we're going to look at 7-4 and we're going to do some practice in it. So here we go. So number one, it asks us to solve for x. Well, they're all going to ask us to solve for x unless the directions say otherwise. So probably at number one. So I'll do one the long way and then I'll remind you with two the shortcut that we learned with this. So I'm trying to find triangles. There are three similar triangles in here, and I'm trying to find a way to set two of them up. So like I could set up here, be like, okay, I got 35 and x, like that's one of my triangles, right? And then if I look at this one, it's a 4 and then x. And these are similar by the property we learned when you take an altitude from the right angle. This is always true. And the other thing is that if this is let's say this looks like the longer one of the two legs, this is the longer leg, that's the shorter leg. In the other triangle, it's reversed, and that'll be the long leg, that'll be the short leg. So what I can do is I can say, well, if I'm gonna take my long to long, I could do 35 to x equals, then I would need to do x to 4. So I can go through and solve this. 35 times 4, everyone knows is, just kidding, 140. So we can say 140 is equal to x squared. And I'll just take the square root of both sides. And the square root of 140 is approximately 11.83. All right. So of course the shortcut is, anytime we have this set up and we're looking for x, we just take one of the numbers, put it over x, and then put x on the top and put the other number. I could have swapped the numbers, it won't matter, because at the end of the day, we're going to be cross multiplying. 16 times 4 is 64, is equal to x squared. Take the square root of both sides, and we get x is equal to 8. This time it's exactly 8. So a little bit repetitive there. Then we get to number 3, and number 3 asks us for a whole lot of information. It gives us that h is 6, so this whole thing is 6, and it says s1 is 3, so this is 3. Wait a minute, if that's 3, what's s2 then? Well, 3 and s2 together get me 6, so I can do 6 minus 3 and figure out that this is also 3. Okay. So now, if I want to find U1A and U2, one thing I know is I have this situation, right? I have my right angle. I have 3 and 3, and then I want to know A. Well, couldn't I do 3 over A is equal to A over 3? Like, it's the same setup as the earlier questions. So let me do this. I'll cross multiply, I'll get 9, and then that is equal to A squared, and I'll take the, wait. I don't need my calculator for that. I know the square root of 9. It's 3. So A is 3 as well. That's kind of silly. Okay, 3, 3, 3. Okay, fun. What do you bet U1 and U2 are 3 as well? They're not. They're not. Don't get your hopes up too much. Okay, so let me see. If I want to find U1, well, I could say U1 is here, and then we have 3 and 3. I could also be like, I got the whole big triangle, right? I could say I have U1 and 6, right? So, and it looks like 6 is my hypotenuse, my longest side, and here U1 is my hypotenuse, my longest side. So I could put like U1 goes with 6, and then I could put like, if I pick 3, you know, wait, which one's U1? U1, that's the short side here. It's a short leg, so I would need to take the short leg, which is 3. And I could do, so I did this triangle on top, so I'll do this triangle on top again, and I'll put U1 on the bottom. Oh, hey, it's the same kind of setup, right? 6 times 3 is 18. U1, we just call it U1 squared. Kind of looking like an N the more I'm writing U. If I take the square root, of 18, I get 4.24. So U1 is approximately 4.24. So I don't know about you, but I found all these. I'm pretty sure that U2 is also going to be 4.24, but let's just be careful. Yeah, no, look, because we have a 3, 3, and then U2. That's like 3, 3, and U1. And so I might wind up having to take the long side instead of the short side, but all the calculations are going to work out to be exactly the same. Okay, number 4. I shouldn't have put number 4 on here. It involves advanced solving techniques that we really haven't gone over this year at all, and you probably did not go over in Algebra 1. So I'll do this setup just since I put it on here, but I'm not going to finish it for the sake of, or I'll tell you when to skip. So the setup is still kind of tricky, but I see X, and I see I have this triangle, and then I also could be like, we got the big triangle right here, right? So if I do that, let me take X over. So X is my little side of this, and then the little side of the big triangle is 12. And then the other side I have of my pink-purple triangle is 12, which is my hypotenuse. What's the hypotenuse of my big triangle? It's 10 and x together, 10 plus x. So this is something we haven't learned how to solve this, but if the setup makes sense, then that's all I really am looking for my class this year. But I'm gonna keep on solving, I'm just gonna finish it. So I'll cross multiply, I'll get 144. And then when I multiply these, I get x times 10 plus x. And so what that looks like, we distribute the x, we get 10x plus x squared. And then when we have x squared in an equation and it's not just a plain x squared, there's another x that we're dealing with, we can't just take the square root of both sides. We have to use some special methods, and they always involve setting it equal to 0 first. So I'm going to subtract it by 144. And over here I have 0 on the right-hand side. I'm going to put the x squared first, then plus 10x minus 144. And what we do here is and again, I'm not expecting you to be able to do this year. This is something that you're going to spend more time on in Algebra 2. But just in case you're curious and you're here, I'm going to go over it. So we're going to factor this. And you may have factored before, but we're using the zero product property, which is that if two factors multiply together equals 0, then if either one is 0, the whole thing is 0. So I'm trying to kind of reverse foil this, and I need to multiply to 144 and add up to 10. So my first guess with this is like, well, let me try 12 times 12, that is 144, but I'm gonna make it negative, so I need one positive and one negative, but the problem is negative 12 plus 12 is 0. I need to add up to 10. So I'm like, well, what else? 144, is it divided by 14? No. 144 divided by 16? Oh, it is. Okay, 16 and 9. If I make one of those negative, it doesn't add up to 10, though. It would only add up to, 7? So I'm like, well, what about 18? 144 divided by 18. Hey, 18 and 8. So I could say x plus 18, x minus 8. And then what you do is you set each of these equal to 0. You say x plus 18 is equal to 0, x minus 8 is equal to 0, and you solve them both. You subtract the 18, you get x is equal to negative 18. Negative numbers are not allowed in a diagram like this, so I know that my only choice is that x is equal to 8. So again, didn't expect you to be able to do any of that. If you watched through all this, you should let me know that you did that if you understood it. That's really cool. All right, on to number 5. How tall is the building? Back to stuff that we can do. So it's asking for this, right? How tall is the building? So I originally thought this was like impossible and stuff we couldn't do. But the more I thought about it, the more I found something that I can use. So I have a triangle here with x and 120. I don't know the bottom side here, though. I don't. And that's okay. You don't need it. I do, however, know this complete triangle. This is 120, this is 160, and this is 200. And so what I can do is I can say, well, I know that I can put 120 with 200, right? I can put 120 with 200, and that's going to be equal to x with, and now I've got to figure out which one of these goes with x. So if I look at this triangle here, the smaller triangle, it looks like that's the shorter side and x is the longer of the two legs. So the longer of the two legs here is 160. And let's see, now I should be able to cross multiply and do 120 times 160 and get 19,200 is equal to 200x. And so I'll take 19200 divided by 200, and I get x is equal to 96 feet. I've done this one twice. Did I get? Oh, I did it differently last time. Let me make sure I didn't make a silly mistake then. Let's see. Oh, I think I made a silly mistake last time. Yeah, because x is the longer of the two sides in that, yep. Okay, all right, so anyway, yeah, I made a typo. I'm glad that I'm filming this one and not the first time I did it. All right, so number 6, we'll write a so 96 feet, yeah, sorry. Okay, so number 6, we'll write a similarity statement regarding the 3 triangles in the diagram. So I'm just gonna name the big one and then figure out how to make the smaller ones fit. Remember, it makes 3 similar triangles, so I'll do JKL. JKL, I know that that is similar to another triangle. And so, well, I ended with my right angle. So if I'm talking about these 3 points, this K, M, and L, like whatever order, J, K, L, I ended with my right angle. So on this one, I'm gonna end with my right angle, which is at M, right? And on here, it looks like I started out at the, if I look at K and J, it looks like J is a little bit of a smaller angle than K. So I'll start with my smallest angle, which looks like L. So I'd say LKM. And then for my other triangle, I'm gonna do the same kind of procedure. I end with my right angle, which on this smaller triangle here, M is also my right angle. So I'll end with M, and I need to figure out where I start. Well, it does share the angle J, so I'll start with the angle J, and then it'll be JLM. All right, sorry for all the sniffles. I think I'm having seasonal allergies right now. All right, so number 7, we're solving for x. They're letting me know these are similar triangles. So I could do, here's the thing. I'm not sure if 12 is similar to 8 or 12 is similar to 36. And I think you could make an argument that there's not enough information to know. So since these weren't labeled, we really do have license. I'm gonna say that the way that they're standing right now, 12 is similar to 8. And that means that x is, or proportional to 8. And that means that x is proportional to 36. So if I cross multiply, I'll get 8x on one side, and I'll get 12 times 36 on the other, which is 432. We'll just divide that by 8, and we'll get that x is 54. If you had thought that 12 instead went with 36, you would get 12 over 36 is equal to x over 8. And let's see, what do you end up getting in that one? That one you get 2.67, or 8/3. So I would be fine with either one since the directions were not clearer. All right, number 8, it says, how are these triangles similar? So, or are they similar and how? So if I look, I have a single angle marking and then a double angle marking. this one has the same thing. So they are by a similarity. They share two angles. If I look at this one, again, I'm gonna have to, I'm not sure which way they would be similar, so I'm gonna have to check a couple of things. So if I check 68 over 64, because 68 and 64 could go together, I get 1.0625. And that means that 80 would go with 52, right? 80 over 52 is, oh, I got a different number. So by that, it's not similar in that direction, but maybe 80 went with 64. Like instead of 68 going with 64, maybe 68 goes with 52. So let's try that. Let's try 68 and 52. I get 1.307, and then if I try 80 and 64, oh, again, I get 1.25. It's a different number. These would need to match, or these would need to match, and then we would have to go and check the final, the 110 and the 80. Oh wait, 110 and 88. My bad. 110 and 88, and that gets me 1.25. So even though, like if I use these two, I get 1.25, 1.25. That's different though. So it's not SSS similarity. There is no similarity. All right, then let's look at our last one. Our last one confuses a lot of people, but remember, we have two lines intersecting like this, or two line segments intersecting like that, meaning we have vertical angles. And so since we have vertical angles, I know that I'm going to use an angle. I'm potentially going to use an angle somewhere in my similarity statement. Well, let's see. Does 1 go with 8 and 2 go with 4? Well, let's see. 1 over 8, 2 over 4. Oh, they're off screen, sorry. I'm not getting the same thing both times. What about 1 over 4 and 2 over 8? Hey, look, we get the same thing both times. So since this side is proportional to that side, this side is proportional to that side, we have something called side angle side similarity. What I meant to write was similarity. All right, so, yep, because 1 over 4 is equal to 2 over 8, which is equal to 0.25. You could have done it the other way around. You could have done 8 divided by 2 and 4 divided by 1. Both of those are 4. Remember, as long as you do big over big or small over, or sorry, big over small, just do it every time, or you do small over big, just do it every time. It's gonna work. All right, I do hope this video was helpful. Bye.